Hi, so this is going to be lesson 4, and we're teaching out of the Algebra 2 Saxon textbook. Lesson 4 is all about the distributive property and solutions of equations, and we're going to introduce a slightly different idea of adding and subtracting things on both sides called change sides, change signs. So the first thing that they want to introduce you to in this lesson is the distributive property. So I was just going to do an example of the distributive property. And what they're wanting to show here is just show a simple example of the distributive property. Remember, to distribute something means to kind of give out to each term. And so what we're doing is we're multiplying whatever's on the outside. If we have a set of parentheses, whatever's on the outside, we're going to multiply it by each term inside the parentheses. We're going to distribute it to each term inside the parentheses. So what you're doing here is doing 3 times x, 3x, and then you're going to do 3 times 5. And we're going to put a plus sign in between. We're going to keep that sign there. So we say plus, and then 3 times 5 is 15. So if you were just using the distributive property, that's just a review of that. Then they go into using the distributive property with some of the more complicated expressions that we've seen where we expand powers. So example 1 says expand 4a squared over b. We're going to expand this by distributing this to these other things inside of the parentheses. And right now, I think I'll just teach you one way to do this. You can do it in a slightly different order if you want to, but what I'm going to teach you is just to start, if you see any negative exponents, go ahead and change those to positive exponents by moving them to the other side. We talked about that reciprocal rule. So if I move the b to the negative 2, if I move it out to the bottom, it becomes b to the positive 2. So we're going to change the negative exponents first, and then we'll distribute. So I'll start by showing you, if I were to change just this part, really, if I change this part, make it a positive exponent, I could rewrite this as 4a squared over b. And then this time, if that goes to the bottom, then we're just left with the 1 on top. So we just put a 1 on the top, and then on the bottom we have our a to the 4th, and now we have b squared on the bottom. Okay? Then we have minus 3ba, and you can say ab. They're just written as BA, but just know that that's the same thing as AB. And we'll probably write that in alphabetical order when we simplify everything. But now we're going to distribute. So we start by changing negative exponents. So I'll just put that. Change negative exponents. So that's your first step. Then you're going to distribute. So this will be this step. So when you distribute, you're going to have to think, okay, I'm distributing this whole expression to this one and this one. All right? And when you do that, you got to follow the rules for the powers that we talked about before. When you're multiplying 2 powers, you add. And then later on, we'll talk about some other things that we can do to simplify. So numbers just multiply normally. So this is 4 times 1, okay? Think top times top, bottom times bottom. So 4 times 1 is 4, and then you have your a squared. And then down here we've got a to the 4th, and we're doing b times b squared. So that's b to the 1st times b squared, which means that's b to the 1st plus b to the 2nd, and we can just say that's b to the 1 plus 2. Okay? Again, that's multiplying b to the 1st times b to the 2nd. Okay, so then over here, now we're going to put our minus sign, and then we're going to do 4 times 3, so that's 12. And then this time we have a to the second. We're doing times a to the first. So that means it's a to the second plus a 1, because this is a to the first. So it's a to the 2 plus 1, and then you still have this b here. And again, the reason I'm doing that is because when you multiply powers, you add the exponents. On the bottom, this is just b times a squared. So if I want, I can write the a squared first because I like alphabetical order, and then put b. And now I'm going to simplify, and then I'm going to cancel things out, or use the idea of when you're dividing two powers, you subtract. So let's write this in here. So 4a squared over a to the 4th, b to the 3rd. So I'm just simplifying this real quick. Minus 12, a to the 3rd, b over a squared b. So now we've got it simplified a little bit, and now we can think about really canceling at this point. Okay, and the reason I'm going to do canceling and not think of it as when you divide, subtract, is because I think it wants to have you keep everything with positive exponents. If I were to do the divide, then I subtract, I would end up getting a negative exponent for the a, and I kind of don't want to do that. So what I would do is just think, okay, this is how I normally do it. I just think, okay, I've got a's on the top and a's on the bottom. I've got 2 on the top. I've got 4 on the bottom. Okay, so I have more on the bottom. And so I can think in my mind, how many more do I have on the bottom? I have 2 more on the bottom. So when I write my simplified form, I'd say 4, and these 2 a's are getting canceled with 2 of the a's on the bottom. And I have 2 left on the bottom. So just the 4 is left on the top, and I've got a squared on the bottom, and I have b cubed. Okay? We'll try that again with this next one. So with this next one, if we're simplifying this, we look here and we go, okay, I've got 12. And then look at the a's. We've got a's on the top and a's on the bottom. There's 1 more on the top, which means the 2 a's down here are going to cancel with 2 of the a's up here. Because this is like a times a, and this is a times a times a. Okay, so there's 1 more on the top. So we're going to cancel out the a squareds on the bottom. And I just usually just cancel this little 3, and I put a 1, meaning I canceled out 2 of the a's. Okay, so I've got 12a, and then here, these are the same power, so the b's just cancel out completely, which is nice. And then we're just left with this. This is our final answer. We cannot simplify this anymore. We don't have like terms right now. So we're just going to leave this as our final answer. Okay, so we're going to say change negative exponents to positive ones, distribute it, distribute whatever's outside and into the inside, and then we can just say simplify. We can say cancel. So cancel things on the top and the bottom. Let's try another one. So this is example 2. Example 2, very similar. We've got a to the negative 3, b to the 0 over c. And we're multiplying that by a squared bc over c squared minus 3a to the negative 2 over b to the negative 2. So again, first thing, let's change the negative exponents and make them positive. I can see several on this one, okay? So this one needs to be changed. We need to bring that down to the bottom and make it a positive exponent. And then this is interesting. B to the 0. That's something I can simplify now as well, because anything raised to the 0th power is 1. So that means this whole thing, b to the 0, that's 1. So when I rewrite this, I'm just going to replace this with a 1, and I'm going to move this to the bottom. Okay, and then I look over here. These are some other negative exponents here. The a's need to be moved to the bottom, and the b's need to be moved to the top. Okay, so we're going to do that. So again, this gets moved to the bottom, so it's no longer up here, and b to the 0th power is 1. So only thing left up here is 1. All right? And then, like I said, I'm moving the a to the negative 3. I'm moving that to the bottom. I'm going to make it positive, so this is a to the positive 3 on the bottom. And then I have the c that's already there. Okay? So now, I'm going to rewrite this first term in the parentheses down. And then I'll rewrite the 3. Now remember, the 3 is not being raised to a negative exponent, so we're not moving that. It's not attached with the a to the negative 2, so don't make the mistake of moving the 3 as well. Just look at the letter that has a negative exponent. That's what you're going to move. So we're going to move this to the bottom, and we're going to make this a squared on the bottom, positive a squared. And this one's going to go to the top. We're going to make that b squared on the top. So now we've changed all the negative exponents to positive ones, and now we're ready to distribute. That's our next step. So we're going to multiply. Really, this is a 1 really out in front. If it's not written, it's a 1. So 1 times a squared bc is just a squared bc. On the bottom, I'm going to do a to the 3rd. And then here I've got c to the 1st, really. Okay? So remember, c to the 1st times c to the 2nd is c to the 1 plus 2. It's c to the 3rd. Okay? You've got 3 c's there altogether. And again, when you're multiplying powers, you add the exponents. Now we're going to multiply this other one. 1 times 3 is 3. Notice I'm just carrying this subtraction sign through here. So 1 times 3 is 3. And then I've got b squared. And then on the bottom, I'm doing a to the 3rd times a to the 2nd. So that's going to be a to the 3 plus 2. So I've got a to the 3 plus 2, and I have that c that's being distributed as well. Okay, that's c to the 1st power. So now I'm going to simplify this, rewrite it. A squared bc over a to the 3rd c to the 3rd minus 3b squared over a to the 5th c. And now we want to simplify and cancel things that we can that are on the top and the bottom. So again, using that thing we talked about, we're going to compare the top and the bottom, and we've got 2 a's on the top, 3 a's on the bottom. So 2 of those a's are going to cancel with 2 of the a's down here, and we're left with 1 a on the bottom. So I'm just going to cancel out that whole thing, the a squared, and I'm going to just cancel out the 3 and put a 1. All right? So it's a little tiny 1 since it's an exponent. The c's, notice again I've got 1 c on top. There's a 1 here. 1 c on top, 3 c's on the bottom. So one of those c's is going to cancel with one of the c's here. So I'll cross that whole thing out on the top because those are all going to be gone. And instead of a 3, I'm going to put a 2 because one of those c's gets canceled. And then over here, notice we don't have anything that's the same on the top and the bottom. So this one's actually good. So our final answer, what's left, is b on top. So we have a b on top. Both the a squared and the c to the 1st were canceled out completely, so that's all that's left. On the bottom we have a to the first and c squared. So I'm just going to put ac squared, meaning a to the first, c squared. And then I just copy this other part, 3b squared over a to the fifth c. And there's my final answer for that. So that is all that they give you on expanding using the distributive property and powers. Then they go into solutions of equations. So equations that have the same solution sets are called equivalent equations. You've probably done several examples where you solve equations. They do give a nice summary of what to do for solving equations on page 38. The first thing you want to do is eliminate parentheses, and then you're going to add like terms, and then you start to get the variable on one side and the numbers on the other, and just try to get that variable by itself. We'll use those steps to solve the equations for examples 3 and 4, and then we should be we'll be close to finishing at that point, okay? I'm going to switch pages here for you. All right, so this first one is going to be example 3. We've got a pretty decent equation here. It has parentheses. So we are going to have to work with the distributing again. Some of these aren't too bad. It looks like one of these kind of has parentheses, but it's not needed. All right. So here's the example. And what they want to do first is they say eliminate the parentheses. And so you're going to have to use the distributive property if you're going to do that. So if you look at this one, if we were to use the distributive property for this to eliminate parentheses first, we kind of have to imagine there's this 1 out in front. This is -1 that's out in front of this. If you just have a minus sign, you can think of that as a -1. And you're going to distribute that -1 to both of these inside of the parentheses. Okay, so again, first we're going to rewrite the whole equation without parentheses, and then we'll decide what to do from there. So 12, and we write that, and then we do -1 times 2x. That's going to be -2x. -1 times 5. That's a -5 or a -5. Okay, so we've eliminated parentheses on that side. Then on this side, -2. And this is really just a 1 out in front. This is the set of parentheses I was trying to say isn't really required. You can really just take those parentheses out, but if you want to think of it as multiplying everything by a 1, a positive 1, you can do that. It's just going to keep it the same. So if I do 1 times x, I just get 1x, or just x. If I do 1 times -3, I just get -3. So really those parentheses just go away. The next step they say is add like terms on both sides. So we look on the left side and we see that there's a 12 and a -5. Okay. Over on the right side, you can see there's a -2 and a -3. We're going to have to combine, on each side, combine the like terms. So 12 minus 5, that's 7. So we have 7, and then minus 2x. We just rewrite this one. He doesn't have a like term. Over here, -2 minus 3, is a -5. So we've got a -5, and we've got plus x. Okay, and it's okay if you rewrote those in slightly different order. You could have said x minus 5. It's okay. As long as you get the general idea that you're combining the like terms. And then you want to basically move your variables to one side. Typically, you guys see people moving them over here to the left. If you want to get rid of variables on the right, you're going to have to undo what's being done here. So if we have a plus x, we're going to have to do a minus x in order to get rid of it on the right side. And whatever I do to this side, I have to do it to this side. That's the addition rule or subtraction rule for equations, basically. And what I'm going to do is if I subtracted it here, I'm going to have to subtract it underneath the term that has the x. Okay? So we write that. And then we're going to simplify and see what's left here. So we've got 7. Negative 2x minus 1 more x is negative 3x. And then now we're left with a negative 5 over here. And these x's are gone. We got rid of them. Okay? Now we'll move the numbers over to the right side. We're going to get rid of the number 7 over here, and we're going to move it over here. So again, it's positive 7 right now. So in order to get rid of it, I got to subtract 7 from both sides. So I'm just going to show that I'm subtracting 7 on both sides. It gets rid of it here on the left, and then we're left with negative 3x equals negative 12 on the right if we simplify the right side. And the final step, now that you've gotten the variables on the left, the numbers on the right, now we want to get the variable by itself. We want a 1x, so we have to divide both sides by negative 3. Okay, right now it was being multiplied by negative 3, so in order to undo that and get a 1, you have to divide by that same amount. Okay, and that goes with the multiplication and division rule for equations. So, and all of that's on page 38 on the top. So this creates a 1x, or just an x, okay? It's not a 0, it's actually a 1, and that's what you want. You don't want to get rid of the variable, you want just 1x. And then negative 12 divided by negative 3 is positive 4. So there you go. And so that's an example where there's no fractions, and then they're going to show you example 4 with fractions. So they ask you to solve this equation. And it's got lots of lovely fractions. And so I think what we'll end up doing is solving it the way the book solves it, I think. But there is another way we can do it, and I might show you that way as well. So, because later on you're going to want to learn how to get rid of fractions. So the first step really with either methods is you do want to get rid of the parentheses by distributing. So let's do that. So we're going to multiply both of these by a 3. We're going to distribute this 3. And what we might want to do, just to make it easier, is say that's 3 times 5/6, and then say minus 3 times the 5/3 x. And that way you can, work with the 3's and cancel things. Over here, negative 1, really, or negative, times a negative is positive, so that gives you a positive 1/2. And then you can say a negative 1 or negative times a positive x is a negative x. Negative 1x. So now we're at this point. Let's simplify this. So if you just decide to kind of like cross cancel, you can think, okay, well 3 goes into 6 2 times. So we can say 3 divided by 3 is 1, 6 divided by 3 is 2. So now we know that this is going to simplify to 5 over 2, because this would just be 1 times 5, which is 5, over 2. So I can write that, 5 over 2. And then for this one, this is nice. The 3's just cancel. Okay? So we've got a minus 5, 5's left, and x. And that equals 1 over 2 minus x. So like I said, the book will show you one way where you can decide to get things on the left or on the right. I'll show you that way because it actually works out nicely. but there is one other way to do it by getting rid of fractions, which I might be able to show you later. So let's get the variables. This time I'm going to show you getting the variables on the right. Okay, so let's, imagine we want to get this over on the right side. We want to get rid of it on the left, okay? We want to get rid of this negative 5x. We want to put it on the right. So if we do that, in order to get rid of a negative 5x or a minus 5x, you have to do the opposite. So you add 5x to both sides. So we're going to add 5x. Notice I'm putting it right underneath the minus 5x, and I'm putting it right underneath the minus x here, okay? So we've got 5/2. That just gets carried down. This one's gone. Then we have 1/2. And then here, a negative 1x plus a 5x is 4x. So now we've gotten the variable on the right. Let's get the numbers on the left. So we're going to do that. So in order to get the number over here, we need to get rid of it on the right. So we're going to subtract 1/2 from both sides. And the only reason I'm choosing not to show you that other method is because this is going to be nice the way it works out. Hopefully they'll all work out nicely like this. But if not, like I said, I can show you an alternate method. So 5/2 minus 1/2 is 4/2. Okay, and 4/2 is equal to 2. So I'll rewrite that in a second. Remember, this is going to cancel out over here, and then I'm just left with the 4x. So I'll just simplify. Now I've got 4 over 2, and again, that's 2. So that's just 4x equals 2. So again, that worked out nicely. The very final step to get x by itself is divide both sides by what's out in front of x, which is 4. So that cancels. And then we're left with 2 over 4, and that simplifies to 1 over 2. And so you can say 1/2 equals x. You can also say x equals 1/2. All right? The final thing that they show you in this lesson is change sides means change signs. And what they're trying to say is instead of writing, your addition and subtraction underneath, you can think of it as when you move it to the other side, it will switch signs, okay? They kind of mention here, it says it happens every time we use the addition rule. The term will disappear on one side of the equation and will appear on the other side with its sign changed. So let's go over an example of that. So final little examples on here. So this is example 5, okay? And I'll just show you just a couple of these. So example 5. Example 5 is saying use the rule, change sides, change signs to solve the equation for x. And it gives you this. X minus 2 equals 7. And so what they're saying is, okay, if I want to get the variable by itself, I need to move this. So instead of adding 2 to both sides and writing it underneath like you would normally think to do, you're just going to think, okay, if I move this over to the other side, instead of being a negative 2, it will become a positive 2. So what they do is they just rewrite it as x equals 7 plus 2. They changed the side, they went over the equal sign, so they changed sides of the equal sign, and that means it changed sign. It became a positive 2. So now the answer is x equals 9. Here's another one. Example 6. It says solve for p, and it gives us p minus 3x plus 4 equals 7y. So if you want to get p by itself, again, you're trying to get rid of these two things. So you're going to need to move them over to the other side. Okay? We're going to move up both of those over to the other side. And when we do that, they change signs. So we're going to say p equals. And then we can write, if you want, we can write this one first. Now, instead of a negative 3x, now it will be a positive 3x on the right side. So I'm just going to write 3x. okay? This will become a negative 4, okay? So we could say minus 4. And then you still have your plus 7y that's over there, okay? And then the very last one is example 7. And they say solve for y. So they do a little bit more on this one, like one more step. So in order to solve for y, you're going to need to move this, right? And you're going to need to move this. We're going to move it to the other side, okay? If we move it to the other side, it changes signs. So we're going to say 3y equals, and then instead of a minus 2x, we're going to say 2x when it's on the other side. This is going to become a minus 5 when it's on the other side. And we don't have to write plus 0 because that doesn't represent anything. But unlike the other ones, in order to get y by itself, we have to remember to divide both sides by 3 at the very end. So we're going to divide by 3, divide by 3. What I'm doing is I'm dividing really both sides by 3, but since the right side has 2 terms, I'm dividing each of those terms by 3, okay? So the last thing we get is y equals 2x over 3, or 2/3 x, minus 5/3. So what I want you to try to do is do the practice A and B right below example 7 for ticket out the door, and then you guys are going to do the odds in the book.